Good morning, students. Today we will start the NCERT numericals, the chapter 14, that is oscillations. Read the question first, what he has given. First one, a spring balance has a scale that reads from 0 to 50 kg. The length of the scale attached to the spring balance is 20 centimeter. The body is suspended from the balance. This is the body, means object. The body is suspended from the balance. When displaced and released, this object oscillates with a period of 0.6 seconds. Then what you need to find out? What is the weight of the body attached to the spring balance? I have given the diagram for better convenience. This is a system called as a spring balance. Where we are using a spring balance. The spring balance is a system we are going to use for the measurement of weight of the objects. And here this is spring and this is a scale attached to the spring. If you hang the object to the balance, to the spring or to the scale, then the scale indicating what is the weight of this object. And in the diagram what he has given, the length of scale is equal to 20 centimeter and one object is attached here, and how much maximum weight that the scale is maximum measuring, that is 50 kg. The maximum mass can be measured by using this system is 50 kg. And length of the scale is 20 centimeter and object is attached, and pull the body in downward direction and release it. Then the object is making oscillations. It executes a simple harmonic motions up and down in a vertical orientation. Whenever it is in simple harmonic motion, to complete one cycle means it is going off and coming back to the same point, then we are going to call it as a one complete cycle. In order to complete one cycle, how much time it is taking? 0.6 seconds. Observe very carefully. This is a system. I given the diagram. This is spring. This is scale. Length of scale is 20 centimeter. One object is attached to the scale, and maximum weight that the spring balance is measuring, that is 50 kg. And again, if you pull the body in downward direction and release it from your finger, then the object executing simple harmonic motion to complete one cycle, how much time that the object is taking? 0.6 seconds. Then what you need to find out? What is the weight of this object? You need to find out. Not the mass, you have to find out the weight of the object. Let us take the solution. Let us take solution, and what he has given, let us take m. He has given m is equal to 50 kg, means 0 to 50 kg. It means that this spring balance has maximum capacity to measure how much mass? 50 kg. And next one is length of the scale he has given, that is x is equal to 20 centimeter. Convert in terms of meter, then divided by 100 means 0.20 meter. In terms of meter I have taken, this is the value. And next one, a body suspended from the balance and released. It oscillates with a period of 0.6 second. It means that in order to complete one cycle, the time taken by the body is 0.6 second. Means capital T has given 0.6 second. And we need to find out what is the weight of the body. We need to find out what is the weight of the body. If you pull the body in downward direction, the restoring force is going to be generated inside the spring. That can be find out by using the equation, that is F is equal to K into Y. This equation you know very well. Let us take it as a equation 1. And as you know very well, Newton's second law, F is equal to m into A. Let us take it as a equation number 2. Equate these two. This is F, this is F. Then ma is equal to K into Y. Equate equation 1 and 2. MA is equal to KY. Then here I need to find out M value, K value, then that is M into A divided by Y is equal to K. And here substitute all the value. I am taking this A as a G because acceleration due to gravity I am taking. This is mg, and substitute all the value. M is 50 kg into G is 9.81 divided by Y he has given. Y is nothing but that is X. You can take it as a Y. Displacement from the mean point in the diagram, you can take it as a Y. Substitute all the value. 0.20 meter, this is equal to K. Then K is equal to, you can find out, after finding out the K value, 2452.5 Newton per meter you are getting. Check the answer yourself. This is spring constant. Means if you apply this much of force to the spring, then the displacement becomes 1 meter. That respecting force we are going to call it as a spring constant. And K, after finding the K, we know that for spring the time taken by the body to complete one cycle in spring system can be find out by using one of the theoretical formula, that is T is equal to 2 pi root of M by K. I derived this formula in the theory class. Whenever the object is in SHM in spring system, to complete one cycle, what is the time taken by the body? That can be find out by using the formula T equal to 2 pi root of M by K. And here K I have find out, I obtained already. M you know very well, that is 50, and T is equal to, M we have to find out, means the mass of the body you have to find out, and T is equal to he has given, and substitute and find out M. First squaring on both side, squaring on both side, then you will get, this is T square, this is equal to 4 square, then squaring means root is getting cancelled out, then M by K. I have to find out M. M means mass of the object you need to find out, and let us take it as a capital M. Capital M, because or else you are getting confused with this M. This is the mass, means maximum capacity that the spring balance has to measure. How much mass? 50 kg, that is this one. And capital M is mass of this object. And here T square into K divided by 4 pi square, this is equal to capital M, and T square he has given 0.6 whole square into K value you obtained here 2452.5 divided by 4 into 3.142 whole square, this is equal to M. Then calculate M yourself, you are getting, that is 22.38. M is equal to, capital M is equal to, capital M becomes 22.38 kg. Now we got mass of this object. Mass of this object we have got, that is 22.38 kg. Then what you need to find out? The weight of the object. You know very well, weight is nothing but M into G. Therefore, weight of object, that is W is equal to mass into acceleration due to gravity. Then W is equal to object mass, just now you got, that is 22.38 into G is 9.81, then W is equal to, calculate yourself, you are getting 219 Newton. The SI unit of weight is Newton. Therefore, mass of object attached to the spring is equal to 22.38 kg, and weight is equal to weight of object weight of object is equal to 219.219 Newton. Getting? This is maximum mass measured by the spring system is called as a 50 kg, and displacement means scale length he has given, and I have used this equation. What is the reason? If you pull the object in downward direction, the restoring force is generated inside the spring, that is the restoring force equation, and Newton's second law, that is weight of the object, can be found out by using this equation. Equate those two, then you are getting K. Substitute in this theoretical formula. Mass of the object you are getting, that is m. Weight is nothing but mass into g, that is capital M. Then multiply, you are getting the answer is equal to weight of this object is equal to 219 Newton. And please note down this one. And go to exercise number next, that is second. Read the question first, what he has given. A spring with a spring constant 1200 Newton per meter is mounted on horizontal table as shown in the figure. And next, a mass of 3 kg is attached to the free end of the spring. The mass is pulled sideways to a distance of 2 cm and released. What you need to find out? What is the meaning of the question? First you need to understand the diagram. For convenience we have given here. There is a spring. This is a table surface, and this end of the spring is attached to object, and another end of the spring is attached to the table surface or wall, and the spring constant of this spring is 1200 Newton per meter he has given. It means that in order to produce 1 meter displacement in the spring, how much force is required is called as a spring constant, that is he has given 1200 Newton per meter for this spring. The mass of the object attached to the spring is 3 kg. The force is applying in this direction, means we are pulling the spring object in this direction. This is a table surface, and the diagram I have redrawn here. If you pull the spring object in this direction, the spring is expanding. This position is here, then the spring length becomes increases, then the object is moving to this point because I am pulling the object. To how much distance? From this point to how much length I have pulled the body? 2 cm. Then after pulling to a 2 cm and release from your finger, then the body making oscillations. On the horizontal table surface. And what you need to find out? Frequency of oscillation of this body. What is the frequency of oscillation? In 1 second of time, how many complete cycles it is making? After releasing, it is coming to this point. After releasing, the body is to fro. It is making oscillations like this. This is 1 cycle, this is 2 cycle, so on. To complete in 1 second of time, how many complete cycles that the object is making, that is called as a frequency, you need to find out. Second one, maximum acceleration. At the mean point, acceleration is equal to 0. At the extreme point, because of restoring force acting on the body in this direction, the acceleration of the body is maximum at extreme point. This is mean point, this is extreme point, this is extreme point, this is extreme point. How to find out the acceleration? The formula is there, that is omega square y. What is the acceleration of the body at the extreme positions, you need to find out. Because we need not be find out the acceleration at the mean point, because acceleration at the mean point is equal to 0. Only acceleration is only the body gaining the acceleration only at extreme positions, that need to find out the maximum acceleration. And next, maximum velocity. Whenever the body making oscillations, its velocity is maximum at mean point, that one you need to find out. First, we need to find out the frequency. Frequency is equal to formula you know very well, 2 pi root of, getting, frequency is equal to, before going to that one, for spring we know very well formula, T equal to 2 pi root of m by k. M is mass of the object, k is spring constant, and this is constant. And first find out T equal to into 3.142 into mass he has given, that is 3 kg. K is equal to 1200, and simplify, T equal to 2 into 3.142, and this one taken out, then it will becomes 0.05, and T becomes, we can find out the T value becomes, that is 0.3142 second, and T we have find out, means the time taken for one cycle is, that is 0.3142 we are getting, and we know very well frequency and time relation F equal to 1 by T. The inverse of time is a frequency, then frequency is equal to 1 by T. T you find out here 0.3142, then frequency becomes, calculate the frequency, the answer it will becomes 3.18 Hertz. This is frequency. The first one is over. The first one is over, frequency. It means that in 1 second of time, the number of complete cycles given by the object is 3.18. And next, we can move towards second one, maximum acceleration. The maximum acceleration at extreme points. At mean point acceleration is equal to 0, that's why only we have to find out at extreme points. A max is equal to omega square y. We know very well omega is equal to 2 pi by T, whole square is there, y as it is, and substitute remaining A max is equal to 2 as it is, 3.142 as it is, divided by T you find out already here 0.3142 and whole square, and y value in the diagram, with how much distance we have to pull the body, 2 centimeter. 2 centimeter is a y is equal to 2 centimeter in terms of meter 0.02 divided by 100 means 2 by divided by 100. 2 by 100 is 0.02, means in terms of meter I have taken. Then maximum acceleration you find out yourself. The answer it will become 8 meter per second. 8 meter per second. Whenever the object is in SHM, acceleration at this point is 8, acceleration at this point is 8, and acceleration at this point is 0. And the third one maximum velocity. Third one maximum velocity, that is V max. We need to find out V max is equal to formula omega into y. At mean point, only at mean point we are getting the velocity. At this point velocity is equal to 0, at this point velocity is equal to 0, at this point, at mean point velocity is equal to maximum, that can be find out by using this formula. Omega is equal to 2 pi by T, means angular velocity or angular frequency. Y is equal to 0.02 meter, and substitute all the value 2 into 3.142 divided by the time taken by the body to complete one oscillation, that you already obtained, that is 0.3142 into the displacement he has given in terms of centimeter. Convert the centimeter to meter, you are getting 0.02. Then after calculating all the values, you are getting maximum velocity of the body is equal to, that is 0.4 meter per second. At this point the velocity of the body whenever it is in SHM is 0.4. At this point velocity is 0. At this point velocity is, that is 0.4 meter per second. And please you note down, and here acceleration should be maximum only at extreme point and velocity is maximum only at mean point. That's why note down, and this is the answer. And go to next question and read the question what he has given first. A piston in the cylinder head of locomotive has a stroke. Stroke in the sense, stroke is nothing but a length, that is twice the amplitude. The stroke length is equal to 1 meter. The piston in the cylinder head of locomotive has a stroke of 1 meter. If the piston moves with simple harmonic motion with an angular frequency of 200 radian per minute, what is the maximum velocity of the piston inside the cylinder at mean point you have to find out. This is a piston in the cylinder. This diagram what I have given, this is a cylinder. Inside the cylinder one piston is there. This is mean point, extreme point, extreme point, and inside the cylinder this piston is moving up and down. This is to fro, to fro, to fro, to fro, like this. About its mean point it is making SHM inside the cylinder, this piston. And what you need to find out, what is the speed of this piston inside the cylinder, you need to find out. Speed of piston in the cylinder you need to find out. And the word he has given locomotive. Locomotive in the sense, this is a type of engine moving itself. The type of the engine is called as a locomotive engine. Inside the engine there is a cylinder. Inside the cylinder there is a piston moving up and down, and its frequency he has given in 1 minute of time. In 1 minute of time, how many cycles it is making? That is 200 radian cycles. And you need to find out the speed of this piston inside the cylinder. And one condition he has given, from mean point to extreme point, this is maximum displacement is called as amplitude. What is amplitude? This is a displacement, the maximum displacement of the body from mean point to extreme point. This maximum displacement is called as a amplitude, and amplitude he has given, that is 1 meter. And amplitude, stroke length he has given, that is stroke length is equal to 1 meter. And one thing he has given the condition, the stroke length is twice the amplitude, means twice the amplitude. The stroke is equal to twice the amplitude he has given. It means that the stroke is nothing but the length of the cylinder, that is exactly equal to 2 times of the amplitude. Twice means 2 times of the amplitude, that is he has given. Let us take, that is amplitude. This is A, and x is equal to 2 times of amplitude he has given, and x also he has given, that is 1 meter. And let us take V max, we have to find out from diagram. We know very well x is equal to 2 times of V, because stroke means twice the amplitude. Stroke means length of the cylinder. X is equal to 2 times of V, then A is equal to x by 2, and A is equal to x value he has given, that is 1 meter. 1 meter divided by 2 is equal to amplitude, you are getting 0.5 meter. 0.5 meter. Then amplitude is equal to what is 0.5 meter. It means that the distance from mean point to extreme point, the maximum displacement of the object from the mean point is 0.5 meter. Then amplitude we got, and what we need to find out, maximum velocity. We know the formula, V max is equal to omega into I, then omega is equal to 2 pi by t, or else the omega value directly he has given, that is 200 radian per minute. 200 radian per minute, that is omega value, into y is nothing but maximum displacement from mean point. Maximum displacement from mean point, that is 0.5, then 200 into 0.5 radian meter per minute, and this is 200 into 0.5 meter. If you want to convert minute into second, then divide by 60, then it is converting into meter per second. Then check the answer. V max is equal to, that is around, you are getting, that is 200 into 0 point divided by 60 is equal to 1.67 meter per second. This is answer. Whenever the piston is in SHM, its maximum velocity is equal to 1.67 meter per second. And radian, 200, omega is equal to 200 radian per minute into 0.5. Why I have divided 60 here? I converted minute into second. 1 minute is equal to 60 seconds. That's why I have divided by the value of 60. Then it is converted into 200 radian per second it is converted, divided by 60. Why I converted meter to second, that's why you divide by the number as 60, because 1 minute is equal to 60 seconds. Therefore after getting calculated, you are getting 1.67 meter per second. It is the meaning that the maximum velocity of the piston inside the cylinder is equal to 1.67 meter per second. Getting? You please note down this one. And read the another question. What he has given first, you need to understand. The acceleration due to gravity on moon surface is 1.7 meter per second square. You know very well. The acceleration due to gravity on earth surface is 9.8, but the acceleration due to gravity on moon surface is 1.7. If you release the object here, this is the earth. Whenever it is moving towards the earth, its acceleration is equal to 9.8. But if it is a moon surface, but on the moon surface, if you release any object, whenever it is moving towards the moon surface, then the acceleration of the body become 1.7 meter per second. The g value for earth is 9.8 and the g value for that of the moon is 1.7. This is for earth diagram. This is in case of earth. This is the experiment in case of moon. And here, what is the time period of the simple pendulum on the moon surface if the time period on the earth surface is 3.5 seconds? What is the meaning of the question? Let us imagine it as a earth. Let us imagine here it is a moon surface. Let us take the pendulum is there. I am pulling the pendulum to a certain point and releasing. This is one cycle. To complete one cycle, how much time that this pendulum is taking? That is 3.5 seconds in earth surface. But if you go to the moon, take the same getting pendulum to the moon surface and do the experiment there, then if you pull the body and release it, it is doing one oscillation. To complete one cycle on the moon surface, how much time it is taking, that what you need to find out. Simple pendulum is there in the earth surface. This pendulum, whenever it is in simple harmonic motion, it is taking 3.5 seconds to complete one cycle in earth surface. But if you take the same pendulum to the moon surface, then do the experiment there also. What is the time taken by the pendulum to complete one cycle in moon? That what you need to find out. But keep in mind, the g value for earth is 9.8, g value for moon is 1.7, and same pendulum I am taking moon and earth cases. Therefore length of the pendulum here and length of the pendulum thread here same. At both the side, length of the thread is never changes, that is same. Then time period it changes. First I need to find out what is the length of the thread. The length of the thread is equal to length of thread, or else you can take for earth. For earth T equal to 2 pi root of L by Z. L is length of the thread, T is time taken by the body to one complete cycle in earth surface. Therefore first find out L value and T has given, that is 3.5. Therefore squaring on both side, squaring on both side, you are getting T square is equal to 4 pi square L by G, and multiply G this side, T square into G divided by 4 pi square. This is equal to L. Substitute T is equal to 3.5 whole square into 9.8. For earth I am taking G value 9.8 divided by 4 into 3.142 whole square. This is equal to L, and after substitute all the value, L becomes 3.01 meter. And L is the same for earth as well as moon, because the length of the thread never changes wherever the system is in earth or it is in moon. The length is same. And for moon same equation, T is equal to 2 pi root of L by Z, and T is equal to 2 into 3.142 into root of L is same for earth as well as moon, that's why that is 3.01 divided by G per moon. G per moon is 1.7, don't confuse with 9.8. This value is with respect to of earth and not per moon. For each and every planet G is not same, therefore G per moon is 1.7. It means that if it is earth, if you release the marker here, it is moving towards the earth, then if you want to find out its acceleration, that is becomes 9.81, or if it is a moon surface, then the acceleration of this object becomes 1.7. Therefore the G value is not same for all the planets, then G value is different for different planets. Like that, for moon surface G value is equal to 1.7. I have taken the calculation with respect to of moon surface, that's why you have to take G is 1.7. Substitute all the value and find out the G value you are getting, that is 8.361 second. In earth surface, to complete one cycle, the time taken by the body is 3.5 seconds, but the same pendulum in moon surface, the time taken to complete one cycle is, that is T becomes 8.361 second. Here to complete one cycle 3.5 is there, here to complete one cycle, that is more time is taking, that is because the earth gravity is more than moon gravity. Wherever more is the gravity, lesser is the time. That's why the earth gravity is more than moon gravity, that's why here the object taking lesser time to complete one cycle, and here moon gravity is very small as compared with gravity of the earth, that's why here object taken more time to complete one cycle. That is the T is depending upon the gravity. More the gravity, lesser is the time taken by the object to complete one cycle. Here lesser is the gravity, more the time taken by the simple pendulum to complete one cycle. Therefore you please note down, for earth surface to complete one cycle is 3.5 seconds, but the same pendulum if you taken to the moon surface to complete one cycle, how much time it is taking, that is 8.361 second. Please note down.